Hi everyone, in this video we are going to see how to find the equation of the family of circles going through two given points. Let's suppose we have 2 points like this, point P with coordinates x sub 1, y sub 1 and point Q with coordinates x sub 2, y sub 2. Now how many circles can we draw through these points? Well, actually we can draw infinite number of circles going through these points. Let me draw a few here and you will get the idea. As you can see, I have drawn a few circles here that are going through those 2 points. Now, how are you going to find the general equation of this infinite number of circles? Well, let's try to do the derivation. For the derivation, I'm just going to take a circle like this and let's assume that P and Q, they both lie on this circle and this is one of the family of circles. And then I'm going to take another point R on this circle and let's assume that the coordinates of R are x sub 3, y sub 3. Now if I take R as the variable point, for the locus of R to become a circle, it has to maintain a constant angle between Q and P. I mean, if we join R with Q and R with P, the angle PRQ, that angle has to be constant no matter where R is located if the locus of R has to be a circle, because we know that the same chord subtends same angle on the circumference of the circle. So if this point moves in such a way that it always maintains this constant angle theta, which is angle PRQ, then the locus of this point would become a circle, and then using different values of theta you can actually come up with different circles, and all of them actually will be going through the points P and Q. So I have made a note of that as well, and we're going to do the derivation using these two concepts. Since we know the coordinates of P and Q, using the 2-point form we can easily find the equation of the PQ chord, and that equation can be written like this: y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1. I'm simply using the 2-point form of the equation of a straight line, and we can rewrite this equation kind of like this. And then if we bring all the terms to the left hand side, then our equation would look like this. And let's designate L for the left hand side expression for this equation of the straight line PQ, which is the PQ line. That's the common chord for the family of circles, right? So we can write the equation as L equals 0. Now let's try to find out the slope of PR and QR. The slope of PR can be written like this, and the slope of QR can be written like this. And then if we use the formula for angle between two straight lines, we can say tangent of theta will be absolute value of m sub 1 minus m sub 2 over 1 plus m sub 1 times m sub 2. Now what is m sub 1? Well, that is the slope of PR, and m sub 2 is the slope of QR. So if the angle PRQ is equal to theta, we can say tangent of theta is equal to this. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. So if the angle between two lines is equal to theta, then tangent of theta can be written like this using the slope of the individual lines. From here, if we get rid of the absolute value sign, we can say m sub 1 minus m sub 2 over 1 plus m sub 1 times m sub 2 is equal to plus or minus tangent of theta, because we are getting rid of the absolute value sign, so we have to use plus or minus sign. And from here, we can simply rewrite this equation as m sub 1 minus m sub 2 is equal to plus or minus tangent of theta times 1 plus m sub 1 times m sub 2. I simply multiplied both sides of this equation by 1 plus m sub 1 m sub 2. And if we rewrite the equation, we can write it as 1 plus m sub 1 times m sub 2 is equal to plus or minus cotangent of theta times m sub 1 minus m sub 2. And then I'm going to plug in the values of m sub 1 and m sub 2. And let's see what happens. So our equation is going to look like this. And then if we simplify it a little bit, the left hand side of the equation will look like this and the right hand side of the equation will look like this. And if you notice carefully, the denominator is same on both sides, so they will cancel out each other, and then we can rewrite our equation like this. On the right hand side I have removed the parenthesis, on the left hand side I still have the parenthesis, but on the right hand side I have intentionally removed the parenthesis. So our equation can be written like this, and here if you carefully see, a pair of terms will cancel out each other, and then finally the right hand side can be written like this. Please carefully notice that I am multiplying a negative 1 outside of the bracket and inside the bracket also. And outside of the bracket, the negative 1 along with the plus or minus sign, it essentially becomes plus or minus sign again. So the quantity inside the bracket can be written like this. And then let's add one extra term here. I mean, I'm going to add and subtract one particular quantity. So I'm adding x sub 1 times y sub 1, and also I'm subtracting x sub 1 times y sub 1. That way our right hand side quantity is still intact. And then I have rewritten the right hand side by rearranging the terms a little bit so that I can do factoring. And the factor form looks like this. And then let's do a little more factoring. Ultimately our right hand side can be written like this. So from here we can say that locus of R can be represented by an equation like this. And if you carefully notice, this particular quantity on the right hand side is actually L, the L that we designated up above. That is the L I am talking about, which is y minus y sub 1 times x sub 2 minus x sub 1 minus y sub 2 minus y sub 1 times x minus x sub 1. That is the quantity L, and we can see that in our new equation on the right hand side. So in place of that, I am going to simply write L, uppercase L. So then our equation is going to look like this. And now if we bring everything to the left hand side, our equation would look like this. And in place of plus or minus cotangent of theta, let's use k as a real number. So if we take a real number k, which can be any positive or negative real number, then in place of plus or minus cotangent of theta, we can use k. So our equation can be written like this. And that is the general equation of the family of circles that will be passing through the two given points. And also please carefully notice that when I rewrote the equation for the locus of R, I replaced x sub 3 with x and y sub 3 with y, because we are trying to find the locus of R and R's coordinates were taken as x sub 3 comma y sub 3. And finally when I am writing the general equation for the locus of R, I am using x and y in place of x sub 3 and y sub 3. So finally, this is the locus of R, and that is actually going to represent the equation of a circle, and we can take any real value for k, any real number for k, and every time we will get the equation of a circle, and each of those equations will satisfy the coordinates of both the points P and Q. Sometimes L can also be noted like this in some books. Some authors prefer to note it like this in form of determinant. And if you evaluate this, essentially L is going to be equal to y minus y sub 1 times x sub 2 minus x sub 1 minus y sub 2 minus y sub 1 times x minus x sub 1. If you evaluate this determinant and if you factor the quantities, ultimately you will be able to come to this particular expression, which is again nothing but L. That's the equation of the straight line going through P and Q. So in some books, if they have written a determinant form in place of L, don't be surprised, it's nothing but the equation of that straight line. It's actually the 2-point form of the equation of a straight line. I hope the derivation made sense. Thank you for watching. See you in the next video.